thanks. I'm actually, I have an Apple Watch, and I'm going to start monitoring my heart rate. It's going to think this is exercise because my heart rate's going to go way up, especially during the live coding portion of this. So we'll see how that works. OK, and it sort of is like exercise. Crystal. So the last time I gave this talk, it was about an hour. So I'm going to 30 minutes of slides and 30 minutes of sort of live coding and questions and answers. I'm going to, I cut down a lot of the slides. I'm going to run through them as quickly as I can so we can get to sort of the demo part because I think that's interesting. And as I'm doing the demo, feel free to sort of raise your hands and ask questions about things. I'm going to be showing things off. But yeah, you might have a follow-up question and that might be a sort of interesting way to understand this new language. But some slides just so you get a bit of a basic overview first. So this is the alternate title of the talk. If you were born in the 80s, this might be interesting. I don't even know if Crisscross made it to Poland, but anyway, warm it up, Chris. I'm about to. Someone asked me to give a 140-character summary of this talk. If you need to leave, this will be helpful. So yeah, the main reason to use Crystal in under 140 characters, I actually made it fit. It has a friendly Ruby-like syntax. It has a static type checking system for safety, which you don't get in languages like Ruby and more dynamic languages. It has a modern standard library. Languages like Ruby and Python, other high-level languages, were developed about 20 years ago. And so their standard library tends to be out of date. It's missing things like WebSockets, which we just heard about in the last talk. That's not in the Ruby standard library or in the Python standard library because it didn't exist. It wasn't a technology that was around when those languages were invented, and it hasn't been added since. So Crystal comes with a bunch of things that you would sort of expect to be in the standard library in 2015, but aren't there in other comparable languages. It compiles into efficient, easy to distribute native code that's using LLVM. And there's a number of other benefits of building on top of the LLVM compiler infrastructure. It's a great project, and I think it's allowing languages like Crystal, but a number of other great new languages to flourish, Swift among them. It has a macro system, which some people think is more of a anti-feature than a feature. But I would argue that it sort of gives you some of the dynamism that you're used to in a static language, right? So it lets you to write sort of macros, which lets you sort of some of the metaprogramming type things that you do in a language like Ruby. You can't do in Crystal because it's not a dynamic language, but you kind of get a little bit of that back with the macro system. And it's self-hosted. Crystal is implemented 100% in Crystal, which is great. So again, unlike Ruby or Python, PHP, which are implemented, I guess there are, like there's Rubinius, right, which is sort of an attempt to implement Ruby in Ruby, but it's far from finished. It's not 100% pure Ruby. Whereas Crystal is implemented 100% in Crystal. So if you learn the language, you also can hack on the language and really understand how things work, going all the way down. And there's some cool features related to that as well I'll show off during the demo. I'm going way too slow. So why should you create a new language? It's sort of like the ultimate yak shave, right? You have some problem you want to solve, and like step one is create a programming language. That's almost always a bad decision, right? There's already a lot of programming languages that exist, and if you want to sort of justify a new one, you're asking a lot. You're asking for all of the users to sort of learn a whole new syntax, right? A whole new language. So you should really be doing something quite different from everything that's been done before. It's not like I think sort of the origin story of Rust is Mozilla wanted to create a new rendering engine to replace Gecko. So they wanted to build Servo, but to do that they needed to make a language first. So they made Rust, and so then they built Rust, and now they're building Servo and Rust, and that'll eventually replace Gecko. But it's this like, 10 years project before that'll ever get into Firefox, right? Maybe even longer. So yeah, building a new language is almost always a bad idea. I think you sort of have to really justify it. So what's the justification for Crystal to exist? Why does it deserve to exist? Because these are the barriers, right? You have a whole new syntax you're asking people to learn. That's a lot, right? Asking someone, like, if you asked me to learn Polish before coming into this conference, I probably wouldn't have been able to do it. And so asking people to learn a new language is asking a lot. You have to write all new documentation, a new standard library. you have to develop a whole new ecosystem, right? All the sort of gems in the Ruby ecosystem, eggs in the Python ecosystem. Is that what they're called? Eggs? Yeah, eggs. And NPM packages, right? You have to sort of re-implement this whole ecosystem. So that's a huge amount of work you're sort of repeating. You should have a good reason to do that. So I'm going to try to make the case. This is not staying on. OK, hopefully that'll work. I'll try to make the case that Crystal sort of deserves to live. Yeah, so hopefully that's compelling. So it actually doesn't have a new syntax. It doesn't ask you to learn a new syntax, or at least not very much if you already know Ruby. And if you don't know Ruby, it's about as easy to learn as Ruby is, which is pretty easy, right? One of the features of Ruby is that it's considered to be a pretty easy to learn language, right? A lot of sort of tutorials to get into programming are written in Ruby or Python or JavaScript or similar sort of high-level dynamic languages. And Crystal borrows a lot of its syntax from Ruby and other high-level languages. So I think that's nice. And the other thing is, OK, you're like, well, it's annoying to have a new language, to have a new syntax, because I can't have syntax highlighting in my favorite Vim, which is how I type the word text editor. Yeah, because it uses basically Ruby syntax, you can use Ruby syntax highlighting. But that's not going to work for when I sit down and I'm live coding. Okay. I'll make it work. I'll just keep touching my head like this. And you'll all know why. I think I have a weird shaped head. Is that what it is? I don't know. Maybe. OK. OK, so there's no new syntax, right? It's not asking you to learn a new syntax. You probably already know the syntax, or you've seen similar languages. And even if it is, it borrows from one of the easiest to learn languages. Ruby's sort of known for being quite readable compared to other languages. So I think that's good. We don't need to worry about the new syntax. What about documentation? Well, this is one of the authors of the Crystal programming language tweeting at Yokihiro Mats, who is the author of the Ruby programming language. And he says, hey, because we're using the same syntax, we have a similar object system, is it OK if we copy some of Ruby's documentation, classes and methods, in Crystal? And Mats replies, yes, I copied from Perl. So you sort of were able to leverage this, standing on the shoulders of giants. And yeah, documentation, solved problem, no big deal. Just copy Ruby. Another advantage of adopting its syntax and object system. So what about the standard library? Well, I was mentioning this earlier. You do have to re-implement the standard library, although that's been done for you by the authors of the language. And I'd say they've done quite a nice job. So it has a test library built in called spec. It's very similar to RSpec if you've ever used that in Ruby, just built right into the standard library. There's CSV and JSON and XML parsing, YAML parsing, but also Markdown, right? So this isn't something you see in, for example, the Ruby ecosystem as part of Ruby's standard library. It turns out to be very handy to write things like documentation in Markdown and have that built into the standard library just there. In Ruby, I think there's 5 different competing Markdown parsers. They all behave slightly differently. I think at least 2 of them were implemented by GitHub. That's just built into the language, so that's quite nice. There's an HTTP client and server built in, right? Modern times, we're building stuff on the web, and you sort of expect that to be part of the language. Ruby has a web server built into it called WebRick that's terrible, and I'll prove that later. But the one that's built into Crystal is actually usable, right? Nobody actually deploys WebRick to production. If you're deploying Ruby, you're probably using Unicorn or Puma or Thin or one of the other sort of production web servers. But in Crystal, you can actually deploy the standard library web server. It's quite robust. So I'll show that off. There's also HTTP clients, including WebSockets. So not in the standard library of languages that were invented in the 90s because WebSockets didn't exist. Now they do. It should be baked into the language, and it is. OAuth and OAuth 2, same story, and a bunch of other useful things, right? So it's sort of the story here is that it's a new language. It doesn't have a huge ecosystem of third-party libraries, but the batteries are included in the language, which I think is quite nice. OK, so what about the ecosystem? Well, as I mentioned, there's not a lot of third-party libraries for it. You can see this as a deficiency. I see it as an opportunity. So if you go on GitHub and search for language : crystal without any other keywords or query, it will return 37 repositories. That's not very many. You'll see the very top repository is actually Crystal itself, because as I mentioned, it's a self-hosted language. So it's implemented 100% in Crystal, and that has about 1,000 stars on GitHub. The second most popular library is one that I wrote. And I think it became the second most popular in less than a month, with only 5 stars. So the lesson is it's really easy to become Crystal famous. And just to hammer it home, it's a bit hard to read on the screen, but it shows you results for other languages for the same query on the side. JavaScript has over 1 million libraries, right? Crystal has 37. So you can be a pioneer in this language. You can be whoever you sort of look to as the heroes and pioneers in the language that you use. There's an opportunity for you to be that person for Crystal, right? To write the very fundamental libraries and basic code to sort of bootstrap the language to be more useful. But it is still quite useful. And if you join the mailing list, you'll see every day there's new libraries, database drivers. There's a MySQL and Postgres driver. There's a MongoDB driver. You can talk to Redis and other systems like that. Every day these libraries are being released, and Crystal is sort of becoming more and more useful. So there's an opportunity for you to sort of get in on the ground floor and be part of that process. So I'll call that an advantage, not a disadvantage, and we'll move along. Why do we need yet another language? Just to sort of sum it up, it's a high-level language. It has Ruby-like syntax, so you may already know it or be familiar with it. It's a garbage-collected language, so you don't have to manually manage memory. That seems like a sort of necessary feature for languages that are invented recently. All modern languages have garbage collection for the most part, or some sort of way that you don't have to do that manually. It's compiled using LLVM, which is a great compiler toolkit. It's statically typed, so you get the safety from that. Although it's a quite forgiving type system. So if you're not used to putting in type annotations everywhere, don't be afraid. Crystal will figure out almost all of the types for you with its great type inference system, and with a cool feature called union types, which I'll talk a bit about during the demo. It also has a macro system, which is quite nice, I referenced earlier. Method overloading, it's self-hosted, and it has great performance. So I'm going to spend the next few slides just talking about performance. This is from the computer language benchmark game. It's 10 benchmarks, and there's synthetic benchmarks, so you can take them with a grain of salt if you want. But I think it says something. And I'll just read out the languages from left to right, because it's pretty hard to read. So on the far left, you have GCC. So it's the C language. And everything else is quantized to that. It's on a logarithmic scale. So the C is benchmarked. However C performs, we'll just call that 1. And if something's a 3, that means it's 3 times slower than C in its performance. Next up that ladder, moving from left to right, we have C++, then Ada, then Rust, then Fortran, then Go, then Java, then Haskell, then Scala. And then there's a big gap, right? So all of those languages I mentioned are within 3 times the speed of C, sort of the median out of these 10 benchmarks. And I would say I would call that fast, right? If you're C or within 3 times the speed of C, that's quite fast, quite good performance. And then there's this big gap, and you have Erlang, Ruby's default implementation, MRI, PHP, Perl, Python 3, and JRuby on the far right, which actually has a better median performance, but more variance than some of the other languages. The worst case performance is worse, and the best case performance is also worse. So, the main point I want to make here, and you can sort of argue about it, but to me there's a pretty clear division between Scala and everything to the left of it, and Erlang and everything to the right of it. And in my mind, that division is between static and dynamic languages. And I think in 2015, if you want great performance, oh, by the way, I should read out the scale. So where Erlang begins, that's about 30x or 25x C, and then it gets worse from there. So Ruby, which is just to the right of Erlang, is about 50x C in the median case. So everything to the left of Erlang is about 3 times the speed of C. Everything to the right of Erlang is 50 times or worse. So that's a pretty big gap, and to me, that's sort of the price of having a dynamic language. You can argue about that later. So I think the reason why that's interesting is because a lot of research has shown that bugs are basically constant. For every 1,000 lines of code that you write in any size code base, a lot of research was done at Microsoft in their operating system group, so like the code for Windows, and this has been confirmed and repeated over and over. There's between 10 and 20 bugs per 1,000 lines of code. That's constant. And so CPU performance is great, but it's not the only kind of performance we care about, right? We actually care about other kinds of performance, right? So here's 3 different graphs. The one on the far left is CPU performance, how much time it takes to execute a program. In the middle, we have memory, which is something else, another type of performance that maybe we care about. But then on the right, we have code, how many lines of code. And again, remembering that bugs is a constant given lines of code, the fewer lines of code that you have to write, the fewer bugs you're going to have. If you can execute the same program in fewer lines of code, it's going to have fewer defects. And so we care about CPU performance, but we also care about having a high-level, powerful syntax, very expressive syntax that lets us write few lines of code so that we have fewer defects in our code. OK, so this is Ruby versus C++. Ruby gets crushed by C++ in CPU performance, but Ruby actually crushes C++ in the number of lines of code it takes, right? So you can implement some programs in Ruby that will perform worse, but do the same thing in about 1/10 of the code. And every example except for one, Ruby is less code than C++ to do the exact same thing, to implement the same program. And I'm just going to show this off with a bunch of Ruby versus a bunch of other languages. And you can, I'm just sort of using Ruby as an example here of a dynamic language because Crystal syntax is very similar to Ruby. And as I'll show in a minute, a lot of valid Ruby programs are actually valid Crystal programs. You can run the exact same code through the Crystal interpreter, a Ruby program, and it'll just work. So I think Ruby is a pretty good proxy for Crystal's language expressive-ness, but Crystal has great performance. So I'll show that in a minute. Here's Ruby versus C++, loses in time, wins. Ruby wins in terms of number of lines of code. Ruby versus Java, pretty much the same story. Closure, same story. Rust. Ruby actually beats Rust in one benchmark, which Rust should be really embarrassed about. Maybe that's fixed now that 1.0 is out. But yeah, anyway, same basic story. And Haskell actually is beating Ruby on in 3 cases in terms of the code efficiency, code compactness, and we'll call that developer efficiency. Ruby beats Haskell in CPU performance in a few cases, but in general, this is the story for dynamic versus static languages. OK, so what about Crystal? How does Crystal perform? Right? If we're using Ruby as a proxy for developer performance and the number of lines of code you need to write, how does Crystal benchmark? And this is a benchmark that shows parsing a big JSON file. And Crystal's performance characteristics are much closer to a language like C or C++ than they are to Ruby. And parsing a JSON file, you can say, OK, that's just one benchmark. But at SoundCloud, where I work, parsing JSON, somebody did the math. We have a microservice architecture, and we use JSON as a messaging format between the services. And even if you don't, maybe you're using something more efficient, message pack or protocol buffers or one of these that was talked about in an earlier talk, which we're starting to do as well. When you serialize it out into the web, right, when you're sending messages over the wire to a web browser, you're going to be using JSON for that. Somebody found that out of all the CPUs in our data center, we're spending about half of those CPU resources just parsing and unparsing JSON between microservices, right? So it's just one benchmark. You can take it with a grain of salt. But I would say parsing JSON is actually a pretty important use case for a modern language that you're using to build web services. Crystal actually has 3 different JSON parsing strategies. It has a schema-based parser, a poll parser, and then the default just sort of JSON.parse implementation that looks like Ruby. And they're sort of within an order of magnitude of C++, which is really fast. And they actually use less memory in certain cases, which is great. And then after Crystal on the list, you have Nim, then you have Python. Rust is about 5 times slower than C++. Go is about 6 times slower than C++ and about 3 or 4 times slower than Crystal. Sorry, the first Python was Python with PyPy. And then the bottom one you see is the default implementation of Python written in C. Ruby didn't even make the list, right? It's on the list, but it didn't even make my screenshot. It got cut off. It's about 10 times slower than C++ and Crystal. So if you're doing JSON parsing in Ruby, you can use very similar syntax to parse the same thing in Crystal and get 10 times better performance. So I think that's interesting. I think that's sort of worth the language existing. So hopefully I've convinced you that it's an interesting language. If you want to get it, you can go to this website. That's the sort of installation README. If you're using a Mac, you can brew tap monastech Crystal, and then just install it using Homebrew. You can also clone it and build it yourself. And some basic resources. This is the website, the documentation. There's a mailing list, which I'd highly recommend joining if you're interested. It's pretty low volume, and the quality of the discussion is pretty high. And that's the Git repo on GitHub. So hopefully that gives you a bit of an overview, and I'll jump into the demo. So you see on this slide, I have a Mandelbrot set. And the reason for that is because the first program I'd like to show is this Mandelbrot.rb. So this is a program that generates a Mandelbrot set just sort of on the command line in the terminal using ASCII characters, written in Ruby. So I'm not going to take time to run through it. It's online. It's actually in the Crystal repository. You can look at it. But pretty basic Ruby code to generate a Mandelbrot set. I'll run it, Ruby Mandelbrot, and you can see what it does. Sorry, that's Mandelbrot2.cr. I want to run Mandelbrot.rb. OK, so this is the one that's fully Ruby compatible. That's a bit hard to see, so let me do it with a smaller font, Mandelbrot.rb. OK, generates a Mandelbrot set, looks like a fractal, cool. So we can take that exact same code and run it through the Crystal interpreter. And it just works. It does the exact same thing with Crystal. Now, you'll notice that I ran it just by saying Crystal and feeding it the exact same file. But Crystal, like I said, has compile time, type checking. I didn't have to compile it, right? There wasn't a compilation step. So the default command is for Crystal to basically, if you give it a Crystal file, or a Ruby file that happens to also be valid Crystal, you can just run it, right? It'll compile and run in one step. But what I'm actually going to do is I'm going to build it into a binary. So I'm going to say Crystal build Mandelbrot.rb, and I'm going to build it with the release flag, which is just going to do some performance optimizations on it. It builds incredibly quickly, and now I have a Mandelbrot binary that I can run like this that generates the Mandelbrot set. So I just want to benchmark if I say time Ruby Mandelbrot.rb, and keep in mind this is the exact same code, right? I haven't changed a single line of it. OK, so Ruby generates the Mandelbrot set in about 0.2 of a second. I can run it a few more times just to show that that's consistent. Now it's 2.7. Now it's 2.0. It's about 0.2 of a second. Let's look at the Crystal version that I've compiled. So that's just going to be this Mandelbrot executable. Let me run it with time. OK, 0.00. You can't, it's so fast you can't even measure it. And the reason for that is because you can do compile time optimizations. It doesn't have to parse through and do all the math. It can figure out that this program is basically just doing a bunch of output and compile it down, optimize it to a bunch of print statements, right? You don't actually have to do the math to generate the Mandelbrot set. It just outputs print statements. I don't know if that's what the Crystal interpreter is actually doing, or the Crystal compiler is actually doing. But the point is, it could, right? You have that ahead of time compilation step where you can do compile time optimizations. So I think that's interesting. And the fact that the same code is running significantly faster through Crystal than it does through Ruby, I think that's interesting. Earlier I mentioned that Crystal, maybe I'll show another example sort of along those lines as well. So here's a Sieve. So this is a Sieve. I can make it a bit bigger. And it just prints out all of the prime numbers between 1 and 1 million. I could change the max, but Ruby's kind of slow, so we don't have time for that. So let's just run Ruby Sieve.rb. OK, again, generating all the prime numbers. Let's time that and see how long it takes Ruby to do that. It takes about a second, right? 1.06, 1.07. It's about a second. 1.10. OK, let's do the same thing with Crystal. Sieve.rb. Again, same unmodified Ruby file. OK, let's build it. crystal build sieve.rb with the release flag. Again, let's run time on this program. So it's about 10 times faster for those in the back who can't see. 0.12, 0.16, 0.13. So it's a tenth of a second instead of a whole second doing the exact same thing. OK. I mentioned Crystal has a built-in HTTP server. I've written HTTP servers in a bunch of other languages. So this is a Ruby implementation of an HTTP server. Looks pretty standard, hopefully. I can start that up by running Ruby HTTP server RB. So that's going to be running on port 2000. And let's just curl that to make sure it's working. So I can say curl localhost port 2000. OK, it returns hello PolyConf from Ruby, right? Basic HTTP server. Let's use Apache Bench to benchmark that. So with a concurrency, I'm going to make 1,000 requests with a concurrency level of 100. So it's going to send 100 requests at a time until it gets through 1,000. Let's do that on port 2000, which is running our Ruby web server, and see how long it takes. OK, so the mean is about 155 milliseconds. The longest took 289 milliseconds. That's Ruby. Let's look at a Python web server. Now, I'm not a Python expert, so maybe I did this wrong. But to me, there was a bunch of examples online of how to do a Python web server. This is a multi-threaded one because I was having some trouble with the single-threaded one crashing. So let's just start that up. Python HTTP server.py. OK, that's running on port 2001, so let's change the port number. And if you look, that one crashes. So it serves 3 requests, and then it crashes. Again, I'm not a Python expert. Someone can come up and show me how to do it better later. And maybe it's like you'd say it's unfair to use the standard library HTTP server in Python. That's not meant to be serving thousands of or 1,000 requests with a concurrency level of 100. But it serves 3 and then dies. So here's the Node version. The Node version actually performs reasonably well. So let's say node http server.js. That's running on port 2002. OK, so that one's pretty fast. The longest request took 70 milliseconds, and the mean took 23. I'm gonna say that does pretty good. And if you look at the implementation for the Node one, it actually looks incredibly similar to the Crystal one. I'm going to turn on syntax highlighting by saying set syntax equals Ruby, and I get nice Crystal syntax highlighting. And if you sort of squint your eyes and go back and forth between the Node one and the Crystal one, or really any of these, they look pretty similar. But same sort of high-level code you'd expect to write. Very sort of Ruby-like code, I think, if you're used to looking at Ruby. OK, let's start up that Crystal one. So first I'm going to build it, http server.cr with the release flag. And then let's run our HTTP server executable. OK, that's on port 2003. Boom, done. Longest one took 19 milliseconds, and the mean was 11 milliseconds. No warm-up time, right? I didn't have to wait for the JVM to start or something like that. Boom. The first request I made, if that was the slowest, took 19 milliseconds. And just to remind you, I'll scroll up. Oh, no, I cleared the screen. But the Ruby one was terrible, right? Like the Ruby one, so like 19 milliseconds for Crystal. The Ruby one's still running. We're waiting, right? 477 for Ruby. So the worst case, actually, what's the fastest in Ruby? I bet the slowest in Crystal is probably faster than the fastest in Ruby. Where does it say fastest? It just shows mean. It doesn't show fastest. Anyway, it's very fast. OK, I'm running out of time. Let me show a couple. Oh, OK, so I talked about all the JSON parsing and loading that we do at SoundCloud. So I wrote a little SoundCloud API wrapper in Crystal. Again, set syntax Ruby. You get nice syntax highlighting. This is what defining. So this is a SoundCloud client library. It's going to talk to the SoundCloud API, get a JSON response back, and parse it into an object. It has this nice JSON mapping function that you can call. And then you just pass it a dictionary of keys and values and how they should be parsed, right? So the ID should be parsed into an int32. The username should be parsed into a string. Last modified is a time. And you give it a converter that sort of tells it how to parse from a string into a Crystal time object. So that's cool. And then just to show another example, So in SoundCloud, you have users, and then you have tracks, Gesundheit. A track in SoundCloud has a user associated with it, right? So if you look here, I'm defining the user that's associated with a track as a SoundCloud user, right? So it's going to know to parse that as the SoundCloud user object, which I just defined in the previous file, right? So you can have relationships between entities and this sort of rich expressive language just using this nice JSON mapping function. The other thing you'll notice at the bottom is I say def equals ID. All that does is it says that if you have two different objects that have the same ID, consider them to be equal for all intents and purposes. OK, so let's run some of that code. I'll just show it. So I have example.cr. And yeah, all this does is it requires the files I just showed you. It initializes a SoundCloud client with a client ID. And then, yeah, first we can just get the Crystal user, or sorry, the SoundCloud user. So if I say Crystal example, this is going out to the web, so hopefully the internet here is good. Fetching a JSON object, parsing it into a Crystal object. And you can see here, OK, this is the user object fetched from the web. And if I ask for a track, that will have an embedded user as well. So quite nice, quite fast. Real world code making network requests, right? You can see the user embedded in there. Here's the user, right? That's me. OK, I'm wrapping it up. So let me just show one more example of this sort of union type system and how that works. So OK, I'm just starting a new file from scratch, foo.cr. I can turn on Ruby syntax highlighting. So if you have an array, it will infer that this is an array of type int32, because that's all I'm putting into it, right? So I initialize it the same way I would. And if I want to append 4 to it, I can do that. I can pretty print A. I'm not going to go through the bother of compiling it and optimizing it. You get 1, 2, 3, 4. If I try adding a character onto that array, like the A character, that will fail, right? And again, because it's using LLVM, you get this nice sort of the squiggly arrow error format. So it's saying no overload matches push onto an array of int32 with the type character. Overloads are an array of int32. You can push int32. So what I could do, of course, if I initialize this with an initial value that had characters in it, then it would actually be of the union type. I can pretty print a.class. It'll be of the union type an array of int32 union character, right? So that means this is an array that if you try pushing a float or something like that into it, it won't, again, you'll get a compile time error. But if you try, it accepts characters or int32s. Now, again, you don't have to do that upon initialization. You can actually do that explicitly. There's some syntax. So you can say this is an array of int32 union character. And if you do that, then you can append a character onto your integer array. Totally works. OK, one more really quick example. Really quick.
Last one.
Really quick, I promise. Yeah. So this is going to be completely valid Ruby code. But the type system in Crystal is going to save your butt. So what I'm going to say is if rand2 is 0, then let's assign A to be the string hello. Actually, let's just make it a number to keep things simple. So A will be 1, else let's set A to nil. And then let's define some function foo that takes an argument. And let's call it let's call it arg +1 or something like that, right? So now, if we call foo and pass an A, what do you think is going to happen in Ruby? 50% of the time, you're going to get 2, right? But 50% of the time, it's going to fail. It's going to crash. Exactly. So let's just prove that. Ruby foo.cr. OK, so we got unlucky. It crashed. But sorry, I should output it so that you can actually see it working. So sometimes you get lucky and you get 2. Sometimes you get a crash. In Crystal, 100% of the time, you will get this. You will say undefined method plus for nil. right? So you get that type safety, which is really nice, right? Anyone in Ruby has seen this error message before, undefined method, whatever, for nil, right? It's basically a null pointer exception. And actually, the person who invented the null reference said it was his billion-dollar mistake. So I think this sort of saves you from making that billion-dollar mistake. I think I'm out of time, but if you have questions, you can find me afterwards. I'm SF Erik, E-R-I-K, on Twitter. If you want to follow me, you can ask me questions there as well. Thank you very much. Two questions?
Maybe we can have at least one question.
One question.
Oh, diffusion. Interactive shell.
The question is there a REPL or an interactive shell like IRB for Ruby? There's not. Again, this is a great opportunity for you to get involved and be a pioneer in the language. So it's actually, it's quite a hard problem to solve because Crystal has global type inference. So every time you type a new line in the shell, you have to either reparse all the code or be really clever about the way you do type inference. But it's possible. It should be possible. There's other static languages that have REPLs, so should be able to do it.
Okay, thank you, Erik.